Hello everyone. Today let us study the molecular orbital picture of furane, thiophene and pyrrole. Okay. First let me take a molecular orbital picture of furane. Alright. Now furane has got 4 carbon atoms and then 1 oxygen atom. Okay. You can see the structure over here. So this is carbon, 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 carbon and 1 oxygen atom. Oxygen atom is here. That means it is of the shape like a pentagon. Okay. This is the pentagon shape with the 4 corners occupied by carbon and 1 carbon or this terminal carbon replaced by what? Oxygen atom. Alright. The 4 carbon atoms and oxygen atom in furane undergoes sp2 hybridization. Okay. Now, how it undergoes sp2 hybridization? The oxygen atom does not go to excited state in this case, whereas carbon atom goes to excited state. Okay. The carbon oxygen and carbon hydrogen sigma bonds are formed due to the overlap of sp2 hybrid orbitals. Okay. And the s orbital of hydrogen atoms. So, sp2 hybrid and s orbital overlap. Okay, that's how you get one sigma bonds. All these sigma bonds lie in one plane. The third sp2 hybrid orbital of oxygen contains a lone pair of electrons. So, it lies in the plane of the ring. Okay. Each ring atom in furane also has an unhybridized p orbital. You can see here each ring atom has got unhybridized p orbital. This is sp2 hybridized orbital. Okay. sp2, sp2. So, each has got 3 sp2 hybridized orbitals. Where are these? 1, 2, 3 for this carbon. This carbon 1, 2, 3. Okay. One of the sp2 hybridized orbital overlaps with the 1s orbital hydrogen atom forming sigma bond. You can see here. Okay. Now, another one overlaps with the neighboring sp2 forming sigma bond. Okay. Sigma bond. So, all the sigma bonds lie in one plane, okay, or in the plane of the ring. Now, each ring atom in furane also has an unhybridized p orbital. You can see here it has got unhybridized p orbital. So, carbon atom this p orbital, this carbon atom this, and for this carbon this p orbital, and for this oxygen atom this is the p orbital which is unhybridized. Okay. These are perpendicular to the plane of sigma bonds. You can see here these are perpendicular to the plane of sigma bonds. Okay. The p orbitals of carbon atoms contain 1 electron. So, how many electrons are present in p orbital? 1 electron each. Okay. And this p orbitals overlap, okay, with the p orbital oxygen atoms containing lone pair of electrons. Okay. So, this p orbital overlaps with the p orbital oxygen atom containing lone pair of electrons. The sideways overlap of these p orbitals produces a molecular orbital containing 6 electrons. So, that total you get 6 electrons, correct? Each p orbital 1, 2, 3, 4 and then 2 are here, okay, electron. Therefore, 6 electrons are involved, okay, in what? P orbitals, okay. So, this is shown here in this figure. The furane shows aromatic property. Why furane shows aromatic property? Because it obeys Haeckel's rule. What is Haeckel's rule? It should contain 4n plus 2 pi electrons. Okay. So, here the total number of pi electrons present as 6. So, when you substitute n equal to 1 in Haeckel's rule, that is 4n plus 2 rule, okay, you will get 6 electrons. Therefore, we can say that this furane obeys one Haeckel's rule. Therefore, it is one aromatic. Okay. Now, next we shall see molecular orbital picture of one thiophene. Okay, thiophene, or it is also called thione. The 4 carbon atoms, you can see here 4 carbon atoms, 1, 2, 3, 4, 4 carbon atoms and the sulfur atom in thiophene, this is sulfur atom, undergo one sp2 hybridization. Okay. Carbon atom goes to excited state and sulfur atom does not go to excited state. Okay. What is the atomic number of sulfur? 16. When you write the electronic configuration, you will get it as the neon. Okay. Neon 3s2, 3p4. 3p4 when you split up and write 3p2x, 3p1y, 3p1z. Okay. So, that is how the electronic configuration of sulfur. So, the 4 carbon atoms and the sulfur atom in thiophene undergoes sp2 hybridization. Carbon S and carbon hydrogen sigma bonds are formed due to the overlap of sp2 hybrid orbitals of and s orbitals of hydrogen atom. You can see here sp2 hybridized orbital of carbon overlaps with the s of hydrogen here, as well this carbon atom also same way, this also same way, okay, here also same way. Other sp2 will overlap with the neighboring carbon forming sigma bond, correct? This side one sigma bond, this side one neighboring sulfur, here neighboring sulfur, here neighboring carbon, okay. That's how all sigma bonds are present, okay, in the axial overlapping taking place, and these are lie in one plane, okay. The third sp2 hybrid orbitals of sulfur atom contains lone pair of electrons. The third sp2 hybrid orbital contains lone pair. Where is this present? Here, this side. Okay, this contains lone pair of electrons. Okay, so it lies in the plane of the ring. So all these lone pair lie in the plane of the ring. All right. Each ring atom in thiophene has an unhybridized p orbital. So each contains unhybridized p orbital. You can see here. This carbon atom, this is the p orbital which is unhybridized. This carbon atom, this is the p orbital which is unhybridized. Okay. This is the orbital. Similarly, this carbon, this is the orbital, and sulfur atom, this is the orbital unhybridized. Okay, so p orbitals contain, okay, at each carbon atom as well as sulfur atom. All right. So it lies in perpendicular to the plane of sigma bonds. Okay. The p orbitals of carbon atoms contain one electron each, and each p orbital of sulfur contains lone pair of electrons. All the carbon atom p orbitals contain one electron, whereas sulfur p orbital contains 2 electrons. Okay, total or altogether there are 6 electrons. Okay, 6 pi electrons. The sideways overlap of these p orbitals, so all these p orbitals overlap sideways. You can see here, these will overlap sideways. Okay, produces one sideways overlap of these p orbital produces a molecular orbital containing 6 electrons. Okay, so this is shown in the here. Okay, 6 electrons are here moving, okay, in p orbitals. All right. So this also obeys Hucke's rule. Okay, why it obeys Hucke's rule? It satisfies 4n plus 2 formula. Okay, n equal to 1. When you substitute n equal to 1, you will get 4n plus 2 as equal to 6 pi. Okay, so that's how it obeys what Hucke's rule, and therefore this compound is also one aromatic compound. Okay. Now next we shall see molecular orbital structure of pyrrole. Okay, so pyrrole contains 4 carbon atoms. You can see here here 1, 2, 3 carbon atoms. Okay, fourth corner is occupied by nitrogen atom. Okay, fourth corner is occupied by here this nitrogen atom. Okay, nitrogen atom, here it should be carbon. Okay, it has 4 carbon atoms and 1 what nitrogen atom. Okay, 1 nitrogen atom. So this should be carbon. Okay, now the 4 carbon atoms and the nitrogen atom in pyrrole ring undergoes one sp2 hybridization, similar to the other 2 molecules. Okay, so here also sp2 hybridization. So in this case, both carbon atom and nitrogen atom goes to excited state. Okay, so when you write the electronic configuration and write the ground state and excited state configuration, you will find that, okay, sp2 hybridization and one unhybridized p orbital. Okay, so the carbon nitrogen, carbon hydrogen and nitrogen hydrogen sigma bonds are formed due to the overlap of one sp2 hybrid orbitals at the s orbitals of hydrogen atom. Okay, s orbitals of hydrogen atom. All the sigma bonds lie in one plane. Okay, each ring atom also has an unhybridized p orbital. You can see here this carbon atom, this is the unhybridized p orbital which is perpendicular to the plane. Okay, this carbon atom, this is the unhybridized orbital perpendicular to the plane of this, okay, sigma bonds. This carbon atom, this is the p orbital. Okay, this should be carbon atom, this is the p orbital, and this nitrogen atom, it has got p orbital. Okay, which is perpendicular to the plane. These are perpendicular to the plane of sigma bonds. Okay, the p orbitals of carbon atom contain 1 electron, and the p orbital nitrogen atom contains lone pair of electrons. You can see here lone pair of electrons. Okay, the sideways overlap of p orbitals of nitrogen atom contains, okay, produces molecular orbital, okay, of 6 electrons. So all sideways overlap. This is the sideways overlapping. So total or altogether there are 6 electrons or 6 pi electrons. Okay, you can see here. Therefore, when you substitute in the Huckel rule, that is 4n plus 2, okay, n equal to 1, n you substitute as 1, 4 into 1 plus 2, that is 6, that means it has got 6 pi electrons. Okay, so this molecule also obeys what Huckel's rule. Therefore, this compound is also found to be one aromatic compound. Okay, now relative aromaticities of furan, thiophene and pyrrole. Okay, we shall see what are the relative aromatic properties of furan, thiophene and pyrrole. Alright. Now in furan, because of high electronegativity of oxygen atom, okay, the pair of electrons are held more tightly by one oxygen. Hence furan has least resonance energy. So furan has got least resonance energy. Thiophene with the least electronegative sulfur atom has the highest resonance energy. Okay. The resonance energies of thiophene, pyrrole and furan are found to be, these are the values: 121 kilojoules per mole, 88 kilojoules per mole, 67 kilojoules per mole. Okay. So and what is the order of aromaticity here? Thiophene is greater than pyrrole, greater than furan. Okay. So this is the relative aromatic properties of what? Furan, thiophene and pyrrole. Okay. So I will stop at this stage. Please go through all these slides. Okay. Any difficulty, please contact me. Alright. Thank you.